Welcome everyone to another Code Remix Weekly. I'm your host, Sam Snyder. Not with me today is Tim, who is busy off giving a presentation. And I believe it will be, now I'm not sure, so it's next week that Tim is going to be at JFall. So if you are in the area for that at JFall, be sure to check out Tim's presentation. Well, I'm sure, yeah, it'll be fun for everyone in attendance. The focus is on generative AI on millions of lines of code, a recipe for success? Question mark. And there will be an interactive workshop there as well. So if you ever want to co-develop a recipe or work on a problem together with one of us who works on OpenRewrite at Modern, one of Tim's sessions or one of these jugs is a good way to do that. Speaking of jugs, Jonathan, I believe, Jonathan will be speaking at this Java user group Wednesday, November 13th, so next week basically. And where is this? Where is this one hosted? Sorry, I should have looked this up ahead of time. It looks like this one is in Dallas, Texas. So if you were in the Dallas, Texas area and want to meet Jonathan, Modern co-founder and original creator of OpenRewrite, be sure to join that jug. I do believe it is free, so anyone in the area, I encourage you to attend. Say hi to John. And then, of course, we have upcoming the upcoming Code Remix Summit in 2025 in Miami in May 12th through 14th. And there is still time to use this Modern VIP code for a substantial discount. I will be there speaking. Most other Modern people will be there speaking. Many prominent contributors from the open source community will be there. So if you've been interested in OpenRewrite or Modern or anything that we're trying to do in the realm of automated software refactoring and moving our industry forward, I would love to meet you there in person in a year. So without further ado, we can get on to today's main subject, which is a recent but long requested innovation in OpenRewrite, and the issue is support for the Lombok annotation processor. And this issue goes back years now. I mean, this fellow requested it in our open source issue tracker in 2021, but we honestly knew it was an issue even before then because we at OpenRewrite ourselves use the Lombok annotation processor quite extensively, and you see it all throughout the OpenRewrite code base and our documentation, as it is common in many a Java code base. And so when I talk about Lombok support, well, what do I mean, right? So, Lombok is an annotation processor which uses annotations to do code generation to eliminate boilerplate in a whole variety of kind of common scenarios in Java development. Things like actually the Lombok test class, which now lives in the OpenRewrite code base, has some good examples of the kinds of things Lombok does. Generating getters or setters or accessors or other common methods that you see in Java classes and beans. And before this change went in, OpenRewrite could successfully parse code like this. And the piece that was missing, the crucial ingredient, was that the type attribution for Lombok generated methods would not be there. Because if you've watched my regular video if you watch this regularly, you might remember a video where I discussed the internals of the parsers and how the Java parser works, which we can open up here. If we go open up reloadable Java 17 parser. So, the way that the Java parsers do their work and turn your code into LSTs so that recipes can run on them is by using the actual Java compiler, Java C, in order to parse and type attribute the code, and then we map that from the compiler internal AST onto our LST. And so we were not including Lombok, we're not configuring Lombok as part of that process. So there was no Lombok annotation processor running, so none of that code generation happened. So in the end, they'd be essentially asking the Java parser to parse code that used Lombok annotations, but without Lombok to turn those annotations into methods or anything. And so this had been a long-standing issue for recipe accuracy, since part of what makes recipes so powerful is having that thorough type attribution for all symbols available. And without this, it could even be more than just Lombok symbols that would be affected. Because, if you imagine you have a method that returns, a type parameter, static tfoo, you could have a method that returned a type parameter like this, right? And would be inferring the type based upon the context this method is called in. And so if that was going into a Lombok generated method, there'd be no way for the Java compiler to figure out what T was. So this wouldn't get type attributed. So it was all Lombok methods would not be type attributed. And anything that interacted with Lombok methods was less likely to be type attributed. And this had broad implications for recipe kind of correctness and comprehensiveness within code bases that used Lombok, but it also affected performance because the Java compiler, at least as we invoke it, tries very, very hard to successfully type attribute everything. So when there are symbols that it cannot type attribute, it repeatedly tries to figure out what type they should be. And so I've seen it be the case that attempting to parse a project that has missing type attribution can take 10 times longer than parsing the same project with all of the important types available. So this should be a big win for correctness of LSTs parsed from Lombok-enabled sources, as well as for the performance of parsing and of parsing those projects in the first place. So that is kind of the upside. Oh, and I should mention that this has all been going in over the past few days. So we're doing a release right now, which kind of includes this for the first time. And initially, it only works on Java 17. So I'm going to bring it to Java 8 and Java 11 and Java 21. I'm going to bring it to all of our parsers. But to start with, it only works on Java 17 because it's so tightly, it's quite tightly coupled to the parsing process. So we have to do, we just have to kind of implement it in each of the Java, the major Java parsers. And when I talk about implementing it, now we can kind of get into what that implementation looks like. And so this is inside of reloadable Java 17 parser visitor. And this is kind of the new code which has been added in this place in order to find the Lombok annotation processor from the class path, configure it, add it to the parser, and get it producing at least some of its ASTs. Now, the way Lombok works is quite intricate. Shout out to this documentation page about the Lombok execution path, as I would not have been able to figure out how to get this working in the amount of time I did if without that documentation explaining how Lombok, in normal circumstances, bootstraps itself and interacts with the compiler. But basically, we see Lombok is on the class path when you're parsing some sources. We enable this logic in order to instantiate the Lombok's annotation processor, and configure the Java compiler to use it. So with just the code we see here, the Lombok annotation processor will run and generate all of these methods and sometimes other statements or expressions or what have you um, as kind of part of that process. But that presents a whole other set of issues for us, because in the end, in the resulting LST, like if we go over to this Lombok test, what putting this getter annotation here is going to do is going to generate an AST element, something like public int get in, return in. So once we have enabled the Lombok annotation processor in our Java parser, we've created a new problem for ourselves, because now when we're trying to map the Java compiler AST, which has been modified by Lombok, to the LST, there are going to be elements in it which don't exist in source. And we still need the LST to print back to the original source code. So essentially what we want out of Lombok support is to get the type attribution, but for the source code to still match, as you wouldn't be able to use rewrite if you go and run a recipe on this and it generates a diff that's going to affect this get in method or anything that comes after it, and then you try to apply that diff back to the source code or apply that patch file back to the source code, and it just crashes and burns and doesn't go anywhere, right? Like Git would not be able to apply the diff because the line numbers would be wrong. The get in method that you're modifying doesn't exist in the original source. So in order to support Lombok, we have to both we have to get Lombok into the Java parser, and then we have to filter out all of the elements that Lombok produces. So we have to enable Lombok, and then we have to clean up after it in order to make sure that the resulting LST still prints back out to the original source code. And so in order to do that, helpfully for like the getter methods, Lombok adds a lombok.generated method, a lombok.generated annotation. So in the loadable Java parser visitor, this reloadable Java parser visitor is the class which is substantially responsible for translating the Java compiler AST into the LST, or into the OpenRewrite LST format. And so it is in here that we need to filter out. Now that we've jumped through all these hoops to get Lombok to produce new elements in the AST, and now we need to make sure those AST elements do not get reflected in the final LST. So helpfully, though, there are signs in the LST for most of the LST elements that we can use to identify, oh, hey, like this method, if a method has this Lombok-generated annotation on it, that means it was produced by Lombok. And there's a little bit of detail here in that adding this annotation only became the default in recent versions of Lombok. So we had to jump through some more hoops to try and make sure that all versions of Lombok, at least once we support more than just Java 17, which has these relatively recent versions of Lombok on it, will always include this annotation so that we can filter out the synthetic generated methods that it produces and give you a parse print idempotent LST. So yeah, so we can use this in method invocations or wherever else to essentially just like, hey, if we're looking at something that was a Lombok generated thing that doesn't actually appear in the source, just skip it. Don't map that onto an LST element, just omit it so that the source still matches. But that wasn't the only hoop we had to go through, because some Lombok annotations don't just generate methods or classes, they generate statements or other kind of structural changes to the code which don't have an impact on type attribution, but do sometimes dramatically change the AST. Which means that it could substantially complicate the parser in order to try and build the right set of heuristics in order to filter out these Lombok generated try catch statements and such from the final LST. And so that in order to facilitate that, we don't just apply Lombok with its set of transformations as is. We actually, for all of the transformations that Lombok has that make changes that are not relevant to type attribution, we try to make an override the default Lombok handlers in order to make less destructive ones. So, kind of sticking with this example of getter, there is a variation on getter which I didn't even know about before we looked at this, but it's called lazy getter, where you could say getter with lazy equals true, and it'll do some memoization in order to helpfully have you skip repeating a costly calculation more than once. And this is actually very simple. The Kotlin language has a feature like this called the lazy. So this works. I mean, they're both called lazy, and they work and do basically the same thing. And that's the gist of it. It doesn't eagerly perform this calculation in case nothing ever calls this method. It waits until the method is actually called to call it and cache the result once, and then it keeps that result in memory in perpetuity after that, or until the process ends or whatever. But all of that, well, a very cool and useful feature of Lombok that the people can take advantage of, has no impact on type attribution, right? This, like, the getter method that it generates is going to be have the same method signature regardless, and indeed that's part of the point. So in order to not have to filter out some of these difficult structural changes on the back half, we filter some of them out on the front half. And you might have seen this Rewrite Java Lombok project pop up, and this is where we have this is not is a set of recipes related to Lombok. Those will end up going elsewhere. Probably most of them will be in Rewrite Migrate Java. Some will probably be in Java. But what this does have in it is all of the kind of implementation details of the things of Lombok that we want to override so they don't change things. So, for example, inside of Lombok, there is a class called handleGetter, which actually implements the here we go. I'll get this text zoomed in a little bit for you. So inside of Lombok, there's this class called handleGetter, which responds to the getter annotation and goes and implements the functionality of this getter annotation. And this is all very cool and interesting to read, but the point is mostly that we don't want it to do. We want it to generate a method that we're going to get the type attribution from that will then be easy to filter out. So what we do is we created a getter handler class, which we inside of our configuration of Lombok in the Java parser override it to use ours first, and instead of the default one. And we basically just go and look at the arguments, and then we say, hey, if the arguments are empty, proceed as normal. If there are arguments, though, let's proceed as if there were no arguments, so that those things we don't really want or don't really or that would really complicate the AST to LST translation on the back half just don't ever get generated in the first place. And for some Lombok features, we're just like, yeah, if this feature doesn't have any impact on type attribution, but isn't otherwise filtered out, or would be hard to filter out, then just kind of override it with a no op. And this does lead to a few areas that are imperfectly covered, and we can get into that in more detail. And then there are some areas like with the all args constructor and the no args constructor where we want to there are some parameters of it where their exact values are relevant to type attribution in the end, and others are not. And so we filter out the ones that we don't have a good way of handling, or that won't work or will make problematic transformations. But yeah, that's the basic idea. Override the Lombok handlers to kind of limit it to the subset that are convenient. Apply Lombok during parsing to produce a modified AST, and then when translating that AST into an LST, we filter out the unwanted elements. And so we've gone through all of the Lombok annotations and at least kind of tried to superficially kind of cover them here. So all the kind of common ones, your getter and your setter and your builder. and toString and everything work like you would expect them to. And the methods generated from these guys will be type attributed, and those recipes will be good and happy. There are a few features where we had to have more limited support for, and I'm fairly pleased to say that these are experimental features of Lombok that are not used very often. But if we do go down and check out some of these less supported ones, there are ones like extension method, which is fairly dramatic, where you can do things like this, like see, like I am null here, and with this extension method, you could call a method on a null object and have this rewritten behind the scenes, an invocation of this or method. So this doesn't actually produce a null pointer exception, and this was just like a whole friggin' can of worms to try and deal with, and not many people use it. And if you do, this one will still not be supported. These files with extension methods will they'll parse. Like when we say we don't support a Lombok feature, you'll still get an LST out the other end, but like this won't be type attributed, right? We've disabled, in our extension method handler, like this guy is a no-op, so none of the many transformations this needs to make in order to implement its functionality are running. So we will at least be in a kind of situation of do no harm, right? With this Lombok support, with the things we don't support, it shouldn't be worse than before. You should just still be in that old situation of being like, well, I've got some elements that aren't type attributed because I use these features. And yeah, like these like on constructor ones, which try to place an annotation on the constructor. That's not super relevant for type attribution. And so we just filter that out. But this situation is mostly supported. Kind of the thing that's missing, the only thing that's like really missing type attribution in the end here is this little at __ guy, and everything else should be type attributed here. So even though this is like less supported, it's still quite supported and should work pretty well. So yeah, that is kind of the gist of how Lombok support works. And I feel like if I had to bet, I feel like there's that using Lombok would be predictive of also using or being interested in OpenRewrite, as both of these projects are in their own way trying to like push the boundaries of the Java language or push the boundaries of kind of programming in general to make it more expressive and changeable than it would be otherwise. So we've had a lot of interest in this over the years, and I'm very excited to now be delivering it. So as we finish the OpenRewrite release that is going on, that my colleagues are seeing through as I present this live stream, give it a try, and let me know how it works. If you have a Java 17 project to test it on, if you're still using Java 8 or Java 11 or ahead of the curve, a little bit, or on Java 21, give it a week and then try it, and I'm sure we'll have gotten the Lombok support into all of those Java parsers by then. And yeah, I'm just really pleased to have removed a major impediment to high performance, high correctness recipe execution on Java projects that use this powerful and useful tool of Lombok. And yeah, I hope all of you are too. So yeah, give it a try. Come say hi to me in the open source community Slack. Let me know how it works for you, and let me know what you do with it. And this obviously opens the door for like a lot of Lombok related recipes. So like this would help out a lot with writing recipes to de-Lombok code if you wanted to take Lombok annotations and remove them and replace them with just having the elements in there explicitly, or to Lombokify code, where if you have a bunch of beans that have a bunch of getters and setters that are tedious to write and you're tired of looking at them and would rather they be handled by Lombok annotations, we can now write recipes to do that stuff. So I don't necessarily have writing those recipes planned, but between my other tasks and responsibility, I'll see if I can't squeeze some in. But if you want those things, will be the change you want to see in the world, and start contributing those. And I think to start with, Rewrite Migrate Java will be the home for recipes that are Lombok related in nature. So yeah, I think that is about everything that I have to say on this subject. And I wish all of you a lovely week. I hope you will all go register for the Code Remix in Miami, Florida. That will be coming up next year. Again, that discount code is Modern VIP for $300 off. And I hope to see you in our community Slack. Let me know how you use Lombok. Let me know what you want to see next from OpenRewrite. And let me know when you're going to be contributing that thing that you want to see next from OpenRewrite. Until next week, I've been Sam Snyder, and next week I'll probably be Sam Snyder then too. See you then. Bye-bye.